Sorry, that's me. So we've got our coordinate plane. Wow. I hope I can't. Okay. So we have our coordinate plane, and let's have theta. Let's have theta be equal to 150 degrees. And I want to build a right triangle that includes that 150 degree angle. And we think to ourselves, we can't have a right triangle that has 150 degrees, but we can build this angle that's being built off of the x value and then build the triangle. That's going to be our theta. And then build our right triangle that comes from it. That means that this angle in here, it's always going to be a relationship like of 180 minus that angle. You have to think about this visually. But that guy's going to be $30 degrees. So with our 30-degree triangle, we know that this is a 30, 60, 90 right triangle. I remember for my 30, 60, 90 right triangle that my side lengths, that this came from an equilateral triangle, right? And I remember that I said, okay, well then that makes this guy 2, the hypotenuse, which plays as one whole side length of the equilateral triangle. This guy is 1, which is going to be half of that equilateral triangle. And then I did Pythagorean theorem once, and I remember that it got me the square root of 3. So this is our remembering of our exact values for applications such like this. So remember that since we're in the negative value of cosine, it's not positive square root of 3 here, it's negative square root of 3. And we could find sine, cosine, tangent with all of those measurements. So that's just building a triangle. We'll find the trig values later on in our practice. Cosine here would be negative because your adjacent side length is negative. Sine here would be positive because your opposite side length is in the positive. That's where this idea of the quadrants, which is positive and which is negative, is coming from. Begin by drawing an appropriate triangle to calculate these guys. I'm going to draw my x and y. I know that I'm peeling off to make an angle that is 120. That results in a triangle that looks like this. I always go straight down from the end of that, so it's always making a 90 degree at the x-axis. In order to find out the remaining angle here, I have to subtract from 180, and that means that it's 60 degrees. So this is a 30, 60, 90. I go in and I label my exact values. This is going to be 2, this is going to be 1, and this is going to be square root of 3. If you have a hard time remembering that, I go for the hypotenuse first, and then I know that the shortest leg, which is opposite of 30, will be 1, and then I know that the remainder is square root of 3. It's just a process you have to get down. So if I want to know what the sine of 120 is, I can actually just think about the sine of 60, and then just try and make sure that I'm accounting for which direction in the coordinate plane I am going. This 1 is in fact actually a -1, but it doesn't matter because sine of 120 is going to be sine of 60, which is square root of 3 over 2. Which then means that sine of 120 equals square root of 3 over 2. Please, please, please notice for your homework that sine of 60 and sine of 120 is the exact same. And it's because both of them lie in the positive of our coordinate plane. Versus the cosine, one will be positive and one will be negative. But if I had I'll explain it later. But that's how you know 60 and 120 add up to 180. And so the sine values of angles that add up to 180 will be the same. Cosine of 135. We get to build it again. We've already done it once. I know that my remaining angle is 45. That would make this 1 square root of 2. This guy is going to be negative because it's going in the negative direction of our x and y coordinate plane. So finding cosine of 135 is going to be cosine of this 45-degree angle. I'm going to call it 45 prime again, just so you realize that it's not actually the cosine of 45, but it's the cosine of 45 in this situation, which means that cosine of 135 is going to be negative square root of 2 over 2. So here, when our angles add up to 180 degrees, cosine values are not the same. Rather, one is positive and one is negative. So they're negatives of each other, not negative reciprocals, just negatives of each other. All right, tangent of 210. We have not done an angle that's greater than 180. So I'm going to think about this as I'm peeling up. I'm going up, 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 and around past 180, but how much past 180? 180 plus what gives us 210? So do 210 minus 180, and hopefully you've come up with 30, which means we're not too far past 180 here. So this is 210 degrees. Building my right triangle, this is what we have. So are we subtracting this guy from 180? Are we trying to figure out how to add up to 180? I want to puzzle out the relationship that's going on here in order to find out that angle right there. Now it's 180 degrees plus that tiny little angle past 180 degrees in order to make this right triangle. That teeny tiny little angle, 30 degrees, is going to be what's in that triangle. Again, you have to draw it. You have to understand the relationship of what's going on with its surroundings. All right, so this is a 30, 60, 90. I'm going to first label the hypotenuse. The hypotenuse is 2. Then I know that the shortest leg, which is opposite of 30, is going to be 1 because it's half of that equilateral side. And then I know that the remaining side length is going to be the square root of 3. I am going to make sure I label my negatives appropriately. Negative is square root of 3 is negative, and now 1 is negative. Not only are we going in the negative for the x, we're also going down, which is the negative for the y. So tangent of this 30, not tangent of the real 30, so we'll call it tangent of 30 prime, is going to be opposite over adjacent. So it's both negatives, they're going to cancel out. So 1 over the square root of 3. I would multiply top and bottom by the square root of 3 and get root 3 over 3. So that means that tangent of 210 is the square root of 3 over 3. Last one.